Alrighty. So our first thing we need to do is we need to figure out what the heck a limit is. We're going to be talking about limits today. So a limit is the y value that a function approaches as x approaches a given value. That says value, not valve. I still feel like that looks wrong. So a limit is the y value the function approaches as x approaches a given value. And we're going to start by doing this with pictures, which is why we have the two different graphs that we're looking at on the paper. And then tomorrow we're going to do it algebraically. If you've got friends in the other one, they're doing it swapped because she forgot the computer at home, so she didn't have the pictures. So they're doing the algebraically first. So we're going to do algebraically tomorrow. And it sounds like really complicated and weird. I promise it's really not. So this is the picture on the front. It says limits, and it's got this picture. Is this one. Okay? So the first thing we're going to say is what is the value at g of 2? What is the value at 2? When x is 2, what's y?
1.
There is an open circle right there, y'all. 3. So the value of this function when x is 2 is 3. The value is 3. It is what it is. What we're asking for here is what is the value that g of x approaches as x approaches 2. The little minus sign means from the left. So we want to know as x approaches 2 from the left. So as x approaches 2 from the left, what value is it approaching? 1. Right? It's approaching this open circle. As my x's approach 2, my y values are approaching 1. G of 2 does not equal 1, but it's what it's getting real close to here. So we're kind of tracing along it. This is how we kind of describe things when it's got these discontinuities. So then let's look at it over here. As x approaches 2 from the positive side, from the right-hand side. That's what the little baby plus means. As x is bigger than 2 and it approaches 2 from the left, what are my y values approaching? 3. If it's approaching 2 different values from 2 different sides, so from the left-hand side it's approaching 1, from the right-hand side it's approaching 3. In general, when it's coming towards 2, can I say what it's approaching? No. So this is when we get our Mean Girls reference, if those of you have seen that. If it's approaching 2 different values, the limit does not exist. Thank you. Awesome. Cool. Huh? The limit does not exist. Oh, if they're approaching 2 different values. Because I can't say it's approaching 1. I can't say it's approaching 3. It's not approaching anything. It's approaching 2 different values. I just have it really close together, so I can't put exist on there. The limit does not exist. D and E is also fine. Does not exist. And we're going to practice this a bunch more times because it's weird and awkward to get used to. And that's totally normal. Once you get the hang of it, they're not too bad, but they're kind of awkward to get used to. So we're going to do the same thing. It's the same picture. So the first thing we're going to evaluate is what is the value of G at 3? What is G of 3? 2. It's that guy right there. So as x approaches 3 from the left-hand side, that's what the minus sign means. So as my x's get real close to 3, what do my y values approach? 3. So the limit as x approaches 3 from the left is 3. So the limit as x approaches 3 from the right, so as my x approaches 3 from the right, 2. Give myself no space to write on here. So just in general then, what is it approaching when it approaches 3? What is the limit as x approaches 3? If it's 2 different values, the limit does not exist. The limit does not exist. They're weird and they're awkward to get used to. I'm going to do another one on this one. So the first thing we're going to do is what is G of 4? 3. It's this guy right here. As x approaches 4 from the left, what do my y's approach? 3. As x approaches 4 from the right, what do my y's approach? 3. What is the limit as it approaches 4? 3, because they match. It's this guy. Okay, so the reason we have these is because sometimes we're going to have something like a hole discontinuity. If this had a hole right here, and maybe it had a value down here, it would have different limits than the value. But it doesn't right now. So we just did 9 limits. Questions on your first 9 limits. Because we have a whole nother graph on the back. We're going to practice this some more, y'all can tell. So there's a whole nother graph on the back that we're going to try this again. And I know it's beautiful image quality. It's gorgeous. All right. So this one's not asking the value. We're just hopping straight into the limit. So we want to know the limit as x approaches 4. So as x approaches 4 from the left, and as x approaches 4 from the right, are they approaching the same value? Yes. What value is it? -1. Oh, you're right. It should not be -4. Let's try that again. +4. It's called I'm not paying enough attention. So as x approaches 4 from the right, and as x approaches 4 from the left, approaching 2. So we got an extra practice one in there because I was reading it wrong. 2. So then we're going to look as x approaches 3 from the left. What is it approaching as it approaches 3 from the left?
Infinity.
-infinity. It was the thought. Just be more specific. Because it's continuing down. If we approach 3 from the right, what is it approaching? 2. I'm just going to change these to be something a little bit easier to see through. So what is the limit as x approaches 3? It does not exist. It does not exist because they're approaching 2 different values. So the limit does not exist. Questions on those 4? Because they're kind of weird. Okay. So then we're going to do 0. I've got 0 from the left, 0 from the right, and 0. Period. So, as x approaches 0 from the left, where is it going? What is it approaching? -infinity. So the limit of g of x as x approaches 0 from the left is -infinity. On this one, we've got 0 from the right. +infinity, because it's going up. So what is the limit as x approaches 0? It does not exist because it's pointing in 2 different directions. It does not exist. They are not approaching the same value. This last one feels different too. We've got as x approaches infinity, what is the limit? Because as x approaches infinity, 4. Because it's continuing straight to the side. This is a horizontal line. And it's got an arrow, so it's saying as it keeps going sideways, it's stuck right there at 4. Questions on these 4? Okie dokie. These are our last 4 that look like this. All right. So we want to know the limit as x approaches negative infinity. Yeah. Have confidence in yourself. It's pointing up. It's going to approach positive infinity. As x gets smaller and smaller, my y value goes up. As x continues to the left forever, the output increases forever. So then let's see, what is the limit as x approaches negative 2? What's it approaching? 3. It's approaching the same value from either side. It's approaching here, and it's approaching here. It does not have a value at negative 2. If I said, what's g of negative 2? Undefined. It doesn't have a value. But the limit as it approaches negative 2 is 3. All right, let's do the limit as g of x approaches 5. As x approaches 5, what is our limit? It doesn't exist. If we look here at 5, it's approaching 2 different values. How about as x approaches negative 5? What's our limit as x approaches negative 5? Yeah, negative 1, maybe negative 1/2. We don't have enough information right there. I'm cool with negative 1. Okay. 3 more questions, and then I'm actually done for the day. Yes, dear. So what we looked at for that one, all right, hang tight. As x approaches negative 5, I looked over here where x equals negative 5. I wanted to see, guys, I'm answering somebody's question. I need you to not have conversations over me. Thank you. All right. So we're looking at where x equals negative 5. So that's right over here. I've drawn this gray line right here. As x approaches from the left, it's approaching this value. And as x approaches from the right, it's approaching this value. We're estimating. We don't have enough information to get a real value. So we're just going to kind of pop in and say, well, maybe it's negative 1. Because it looks kind of lined up. If I'm bad at drawing lines, kind of lines up. If you want to say negative 1/2, I am also okay with that. I just said negative 1 because it made it easier on my life. But that's how we find that out. And if it helps to draw that line, draw that line. Because it helped you guys on the 5. It really did. Okay. Last 3 questions. They're just kind of spread out on my page. Okay, I guess it's 6 questions. Is the function continuous when x equals 0? Right here? x equals 0, that's right here. Is it continuous or is it discontinuous? If I trace this line, can I do it without picking up my pen? Or do I have to boop and teleport? Right? It is discontinuous right there at that purple line. So no, it is not continuous at x equals 0. What type of discontinuity is there? So remember, this is called a jump. Remember what this one is? There's two different words I would accept on it. Asymptote is one of them.
I told you.
Infinite discontinuity is the other. It is an infinite discontinuity because there is an asymptote. So I get the thought process on both. Technically, this is an infinite discontinuity. So I'm going to put that on here. All right. Next one. Is the function continuous at x equals -2? No. What kind of discontinuity is that? That is a whole or a removable discontinuity. That's the technical math name. But I'm 100% okay with whole. How about at x equals 5? X equals 5 is this guy right here. And that is a jump.
Yeah, Billy. No.
Because that's our teleport. It is not continuous. If it has any discontinuity, it is not continuous. So it would be continuous if we asked if x, like at 2, this is continuous right here. This is continuous here. This is continuous here. It's really only discontinuous at the places we asked about, as well as 3. Okay? So, if you look at that listy list on homework, it lists worksheet 1 and worksheet 2. Worksheet 1, worksheet 2. One page. Okay. And honestly, you can do the second half of worksheet 2 today as well. The first page is 100% what we've done. The second half of the second one is exactly what we've done. The only thing we haven't done together is these top 6. And we will do those tomorrow. Okay? Do Thursday, because I probably don't see you Wednesday.
Why not?
They haven't sent the schedule out, but it's PSAT day. I will most likely not see any of you, because usually they just like cancel the first one appears someday. But they haven't sent out the schedule, so who knows who's doing what. But my sophomores and juniors, you will be here for PSAT. You just probably won't see me. Seniors and freshmen are doing career or college or community service. Okay? So, tomorrow we will do the ones that are all equation-y. But it's the same vibe. I'm good at counting. Okay, so you guys can work on this and then maybe not have, homework. We love that. Our Unit 3 test is going to be November 9th. November 9th. Huh?